Alrighty, welcome to section 722, defining the log of an exponential, or defining the inverse of an exponential, which we now know is a log. So a logarithm, or log for short, is equal to the inverse of an exponential equation. An expression in logarithmic form, such as log, that little number is called base 2 of 32, is read log base 2 of 32. To evaluate log base 2 of 32 equals x, you want to think 2 to what power equals 32. Since logs can be used to get a variable out of the exponent, exponential functions and log functions are inverses. So that's the whole point of why we're using logs, is because logs and exponentials are inverses. All right, so converting logs to exponential equations. To convert logarithms to the equivalent exponential form, we do the circle dance. It says that the following two forms are equivalent to each other. So it says 4 to the third is equal to 64, and that's equivalent to log base 4 of 64 equals 3. And again, I call this the circle dance because we start with that base. We go over to the other side to get our exponent. So the base of the log is the base of the exponent. We go to the other side to get the exponent, and then we come around to get what it's equal to. So 4 to the third equals 64. That's why it's called the circle dance. One of my students in the past had trouble with the circle dance, so she came up with the acronym of BAY. So you can also use that if you like that better than the circle dance. So the acronym of BAY, she wrote that under the logs. So the B stands for the base. Okay, that little number is always the base. Then answer, so whatever is in the parentheses is your answer. And then whatever is equal to is your exponent. So base, answer, exponent. That's where that BAY comes from. And again, B is the base. E is the exponent of that base, and then the x is the answer because that's what's by itself. So whichever way you remember helps remember you better, that's what you can use. All right, so here's a little bit of practice. I'll do a couple with you here. So all we're doing here is we're saying, it says write the log forms in exponential forms and then solve. So we're saying 2 to the x equals 32. That's the exponential form. So make sure you write it like that first, because that's part of the directions. And then x equals 5, because 2 times itself, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. For the next one, I would say 2 to the x equals 1/2. And so x, I have a fraction. So whenever I have a fraction, I know I have to have a negative number because that number has to go to the bottom. And I just have, if I cover that up, 2 to the first is 2. So then I would just have -1. So the negative is moving to the bottom, and then 2 to the first is just 2. So I get 1/2. Going with a couple others. Here I have 2 to the x equals 0. Is it possible for the exponential to ever equal 0? And no, there's an asymptote there. So this one's undefined. If I look at this one, 2 to the x equals 1/16. Again, I know my answer is a fraction, so I know I'm going to have a negative exponent. That's how I get fractions. So I just cover up that 1. I think 2 to the what power is 16? 2 to the 4th is 16. So 2 to the -4th would be 1/16. And let's just remember fractional exponents. 2 to the 1/2 equals x. And remember, anytime you have a 1/2 power, or anytime you have a fractional exponent, your numerator is the power and the bottom's the root. The roots are on bottoms of the fractional exponents. So this would be best answered as x is equal to the square root of 2. Because it's 2 to the first, and you're taking the square root of it. There's a few more on page 27. So if we look at, let's say, this one, 10 to the what equals 10 to the 1.2. So remember, anytime you have those equal bases, those bases cancel, and you're left with just 1.2. All right, so I want you to try doing all the rest from 1 to 14. All right, do the rest of 1 to 14. All right, for 15 to 20, it says write the following exponentials in logarithmic form. So now we're doing the reverse process. These are our exponentials. We want to write them in the logs. So this is where the bay may really come into play. So we're going to write log. So we're going to base, answer, exponent. So that might help you. So the base of our exponent is y. Our exponent is 5. And then our answer, what was by itself, was x. So this would be log base y of x equals 5. If we want to double check, y to the 5th equals x. If we go to 16, I write my log, and then I write my b, a equals e. So my base is 3. My exponent is 4x. And my answer, what's by itself, is y. We'll do one more. We'll do number 20. So again, it's an exponential. I want to write it as a log. So I can write my log. And if it helps, write the acronym B, A, E. My base is y. My answer, what is by itself, is 7. And my exponent is x plus 1. So that acronym definitely helps when you're converting from exponential to log form. So I'd like you to try 17 to 20, or 17, 18, and 19 on your own. And then last but not least, you're finding the inverse of an exponential or log. So to find the inverse of any exponential function, we must use the algebraic way for finding inverses. So the first thing we're going to do is switch our x and our y. So if we look at number 21, it is a log, so I'm going to switch my x and y. And then again, the directions say find the inverse. All the other ones were, before this, were saying find the equivalent. Now we're finding the inverse, so we're switching our x and y first, just like we normally do. Then you will do the circle dance to convert exponentials to a log, or a log to an exponential. And again, besides the circle dance, you could also do bay if you'd like. So now, normally when we do the circle dance, the variable's on the right, so I might want to put that x on the right, and now I do my circle. So I'd have 9 to the x equals y. We're going to undo any other operations to get the y by itself. In this case, the y is by itself. So all I need to do is put my inverse sign, and we're done. So the inverse of log base 9 of x is 9 to the x. All right, so that's if it's a log, the inverse is an exponential. If we look at 22, now we have an exponential. So let's see what our inverse would be. So again, first step, I switch my x and my y. So I have x equals 10 to the y. And then I want to get my y out of the exponent. So I'm going to make it into a log. And again, now it may help you to use that bay acronym. So base is 10, answer is x, exponent is y. The y is by itself, so therefore y inverse is equal to log base 10 of x. All right, so number 23 and 24, now we're going to have a little bit more complication to it. So we'll do those two, and then I'll have you try 25 and 26. So for 23, again, switch our x and y because we're asked to find the inverse. to y. I'm going to put my x on the other side so I can do my circle dance in the normal fashion. And so I go 6 to the x equals y plus 1. And now the y isn't totally by itself yet, though. So to get the y by itself, I'm going to have to subtract 1. So I'm going to say y inverse is equal to 6 to the x, and then minus 1 is outside, not in the exponent, it's outside. And then the last one we'll do together is y equals 5 to the 2x power. Again, I switch my x and y first. I want to get the y out of the exponent. So to do that, I have to make it into a log. So the BAY acronym may help you, if you like. So our base is 5, our answer is x, and our exponent is 2y. Now, the only thing is the y is not totally by itself, so I have to divide by 2. And we'd end up with y inverse, because the y would now be by itself. Probably the best way to write this is 1/2 log base 5 of x. If you had log base 5 of x all divided by 2, that's fine. But it's kind of just more traditional. If it's division, put a fraction of it out in front. All right, try 25 and 26. And if you have questions, let me know.